Hello my dear student, I am Navkat Mishra with you to discuss corollary of the Thales theorem and hope you have to enjoy this session. In this session, at first I am going to explain about that what is a corollary of Thales theorem, and then I will discuss its proof. My dear student, in the previous video I was discussed about Thales theorem, and you know about the Thales theorem that in a triangle, if a line has been drawn which is parallel to any one of the side of the triangle, and in this case I have just drawn DE parallel to BC, and it intersects other two sides AB and AC at D and E respectively. In this case, according to Thales theorem, you know that ratio of the side that is intersect by this parallel line DE, their ratio AD upon DB must be equal to AE upon EC. It can also be written as DB upon AD is equal to EC upon AE, because you know very well that A upon B is equal to C upon D. Then you know very well that its reciprocal must be equal, and this is why B upon A must be equal to D upon C. What is its corollary? Corollary is that if you take the ratio of this AB upon any one of the part, that is AD, I have just taken the upper parts of this one, is equal to whole side AC upon AE, means side to its part, ratio of the side with its parts is also equal to ratio of the side of the third side to its parts must be equal, that is tells by corollary. Or you may write that AB upon, it is not necessary that you have to take the upper parts, you may take the its lower part, that is DB is equal to AC upon EC. This is the first corollary that you have to prove, and its reciprocal can also be proved. That means AD upon AB is equal to AE upon AC, and DB upon AB is equal to EC upon AC. So these are the corollaries that you have to prove with the help of Thales theorem. My dear student, so I have just written the corollary in a triangle ABC. This is the task for you, that you have to just prove in a triangle ABC a line DE is parallel to BC, DE is parallel to BC, intersect AB in D and AC in E. Then you need to prove that AB upon DB is equal to AC upon EC, and AD upon AB is equal to AE upon AC. You need to prove. Let's start the first one, and its proof has been started by a basic proportionality theorem. We know very well that AD upon DB is equal to AE upon EC, and you know very well that if A is equal to B, then the law of proportion is that if you add the constant number with both the side, then result is unchanged. And this is why you have to apply the same method in this case. And the constant number I have just selected, that is 1. So AD upon DB plus 1 is equal to AE upon EC plus 1. And after that you have to take the LCM, and that is DB. After that you need to simplify. What we get? Actually AD plus DB in this case, because you know very well that AD upon DB plus 1 can be written as AD upon DB plus 1 by 1. And what is the LCM of DB and 1? That is DB. And when DB is divided by DB, then 1, and when 1 is multiplied by AD, then result is AD, plus when DB is divided by 1, the quotient is DB, and when DB is multiplied by 1, then result is DB. So you have to just write down in the LHS side. And what is in the RHS side? Similarly, you can just write down AE plus EC upon EC. And you know very well that AD plus DB, according to this figure, AD plus DB is equal to AB upon DB is equal to AE plus EC. E is equal to AC upon EC. And you can just see that this is the first corollary that you have to get from basic proportionality theorem. My dear student, regarding second, you have to write down by the basic proportionality theorem, and you know that by the help of the theorem AD upon DB is equal to AE upon EC. That I have just discussed earlier, that it can be written as DB upon AD is equal to EC upon AE, because its reciprocal is also equal. And after that you have to apply the same technique that I have just discussed, that if you add the constant number in both the proportion, then proportion is actually unchanged. 1 plus DB upon AD is equal to 1 plus EC upon AE, because if you add the constant number both the side, result is unchanged. And after simplification you just get AD plus DB, which is equal to AE plus EC upon AE. AD plus DB, by the help of figure you can write AB, and AB upon AD is equal to AE plus EC can be written as AC. So it can be written as AC upon AE. If ratio of any two numbers are equals, then its reciprocal must be equal. And this is why you may write AD upon AB is equal to AE upon AC, and that is the corollary second. So you have to enjoy this session, and in the next session I will discuss the converse of Thales theorem. Keep watching Bandha Classes YouTube channel. Thank you very much.